Welcome back. During last lecture we were talking about the tsunami energy, and with a very simple equation you can calculate the energy which has been produced at the time of mega earthquakes. So, you have ET as your total energy, and then you have the density of saline water or the ocean water, and then you are having the gravity, and then you are having the assumed height of the crustal displacement. So, if it is 25-meter displacement or 30-meter displacement, you can consider that, and based on that you can calculate the energy which has been produced at the time of mega earthquake by tsunami. Now, if you look around the globe, you have several locations which have produced mega tsunamis, and we can say the mega subduction zone earthquakes. And the most vulnerable region and in the world is in the Pacific Ocean, or the countries which are around the Pacific Ocean, like this is South America, and then you are having in North America here, and then you are having Japan, and then of course we come down here to the Sumatra part and all that. So, these are the areas which are capable of triggering large magnitude subduction zone earthquakes and tsunamis. Like for example, this region produced a very huge tsunami by an earthquake which had a magnitude of 9.5 in 1960, and then similarly we have couple of earthquakes which have been marked here, but this was one of the largest over here so far recorded on the earth. And then of course the second largest which we had was around Sumatra, that is along Sumatra Andaman arc. These are a few list of the major tsunamis, but apart from this we have more in the last couple of years, like 2004 and 2011. Now, coming to I will give just a brief glimpse of what was been recorded and experienced in 1960 Chilean tsunami, and this had a magnitude of MW 9.5. So, this is considered as one of the largest one so far recorded, and then followed by this was so this is 1960 Chilean tsunami, and then we are having MW 9.3 or so. This is 2004. This is Sumatra Andaman earthquake. So, these are the two one, and then finally we are having the recent one 2011 Tohoku, which was of 9.1. So, the largest subduction zone earthquake occurred on May 22nd, 1960 in Chile. Magnitude was 9.2, and the second largest earthquake was so far recorded was December 26, 2004 Sumatra with 9.3 magnitude. In some literature there is a mention that there was 1964 Alaskan earthquake was the second largest, but it's just a matter of the decimals here. Okay, that makes that probably that was the second largest. But in terms of the rupture and the damage we had, this was one of the largest magnitude earthquake recorded so far. Now, as I told that along the plate boundaries we are having the most vulnerable zones in the world. One is this one. This has produced the world largest one, and the second one is here, that is Sumatra Andaman. So, these are the two plate boundaries which have triggered large magnitude earthquakes and giant tsunamis during the 1960 and 2004 respectively. Now, as we have been talking that if when an earthquake, a large magnitude earthquake along the subduction zone occurs, it will be followed by giant tsunamis or destructive tsunamis. Now, there is time where you can warn the people to evacuate, and this figure, it shows that 1960 tsunami started its journey from here, and it took almost like 22 hours to reach the coast along the Japan. Okay. So, these are the hours which are been given. So, if you know the velocity and if you know the energy which has been released or the energy of the tsunami, you can model the time it will take to reach any particular region, and based on that you can issue the warning. So, this was this tsunami 1960, what people did over here. I will show a couple of photographs of that region. So, it took almost like 22 hours to reach the Philippine and Japan coast. So, the 1960 earthquake ruptured along a fault which was almost like around 500 kilometers or so, and it released a huge energy which triggered the mega tsunami during that period. Now, we saw one small cartoon that how the tsunamis are been triggered. Okay. So, we have one like subducting plate, one plate oceanic plate, or either we are having an overriding plate is also oceanic. So, one plate is subducting below another one. Some portion of the plate under great friction will be locked, okay, over the time, and the strain will keep on accumulating. So, this will bulge. So, slowly there will be a distortion of this portion which has been shown here. So, the water depths will change, but this will be barely noticeable. But if you have GPS stations, that can at least capture this deformation, okay, over the time, and we can understand and we can know that, okay, fine, this area is getting deformed and will trigger a large magnitude earthquake. So, the previous boundary of the surface has been shown here by the dashed line, and this is the bulge which has been developed because of the subducting plate and the overriding plate here, and finally what we see is an release of stored energy in form of mega earthquakes. Okay. So, this release, the displacement. So, if you see this dotted line here is the previous slide here. Okay, this has been shown. So, what has happened is that over the time when this was locked, this area got uplifted, and then finally during an earthquake when the energy was released, this again was been flattened almost and it subsided. Okay. So, over the time the land level change will take place. Okay. So, the earthquake which was triggered and the displacement between the two plates dislocated the water column at in the ocean. Okay. And this displacement resulted into the formation of the tsunami. So, this explains the formation of tsunami, which will inundate the portions on land far inland actually. So, let us move and see a couple of more slides from this region what happened. Now, this was the area which was extensively affected in 1960, and this what we found was Modine, or we can say Modine, okay, was the region which preserved the old signatures of the tsunamis. Okay. So, we did some field in this region to identify the older tsunamis than 1960, and also we looked at the signatures of 1960 tsunami. So, this was the area which got was affected the most during an earthquake, and if you can see here, what it shows is the path of the incoming tsunami. it wiped off the bridge which was located here. So, this was the conditions in the town in Modine. This shows photographs with couple of pictures, couple of houses. This picture shows couple of houses here. You can see this one here, and then so they had a very wide agricultural field with people staying there. Okay, but after this, if you notice, okay, what happened? It was completely swiped off. Okay, so only couple of trees which have been shown here survived. Rest everything was been wiped off. Okay, and during this earthquake, the land subsided, so the level went down, and then finally this area was every time in high tide was inundated. So these are the most common problems which one will face during subduction zone earthquakes and after that. Okay. This is what they have shown, that first wave came in and then second wave wiped off this house here, okay, a small hut which was been wiped off and the water level raised. Okay. Now this was an interesting thing which was noticed in Japan. The local people, okay, who were looking after the tidal gate stations and all that, they understood or they got that there is a water rise which was an unusual, because there was no high tide during that period. So they anticipated that there must be some tsunami coming in, and they warned the people and then asked them to go on high grounds, and this is what has been done in most of the time. Okay. In 2011 also, the people were being evacuated to the higher grounds so that they will not experience the tsunami, or they are not been killed by the tsunami. So this photograph was taken at 4:40 a.m. in the morning, where people were being moved, and you can see still the people are over here. A group of people are moving towards the higher ground, and then a couple of people are already on the higher ground. So the first large wave reached up to this place. Still these people are moving on within water, and then the second one you can see here. Okay, the same house has been shown here. This is within 5 minutes of the time where the first wave arrived. Second wave came in 5 minutes, and what you see here is the complete inundation of this region. Okay, and then it carried a lot of debris, another 5 minutes, okay, and then finally this was the situation. Okay, and this was the water level raised up to this part in another 5 minutes. So this is what you can do if you understand the process of tsunami. Now coming to the other part that we usually see. Okay, fine. Apart from the Himalayan region, why it is so important for us to understand this process? Because we are not left out with any side from this type of hazard. Okay, in the south we have the Andaman Islands, and this Sumatra Andaman arc has triggered many large magnitude earthquakes and tsunamis in the past. Okay, so this was not the only one. That is, 2004 was not the only one. It has also triggered more similar magnitude earthquakes and associated associated giant tsunamis in the past also. Okay, and if you come to the west side, so if the tsunami has been triggered here along this portion, this whole area will be affected. Not only the Andaman Island, but this whole area will be affected, and also this region. Okay, this is the region of Sundar Ban area, which is very flat area. So this also will be affected if the tsunami has been triggered along this zone. What we have been talking about, that we have the collision zone here, we have another active zone in Kutch. there is in the west we have Makran subduction zone, which has also reported the events in the past. Like 325 BC, there was a major earthquake, and then 1945 another earthquake which triggered the tsunami. So if the tsunami has been triggered here, okay, with a large magnitude, this whole area like Gujarat coast and right coming up to the Mumbai and Kerala and all that, that whole area will be affected by such tsunamis if it is comparatively large as we have experienced in 2004. Now this was like again going back into the Chile part. What happens after that? Okay, so if the area is subsided or if the area is uplift, the environmental changes will be seen along the coastlines. Okay, and this is mostly for the regions which are close to the subduction zones. Like in India, we will not have that much of problem in terms of the land level change along this coast, but there will be a massive change of land level where we are having the islands sitting close to the arc. Okay, so arc is not very far from here; it is somewhere over here. It goes like this. So this will be this area will have more of land level change problem. So in 1960, after that, as I told that large area was been subsided. So which area, the area which was used for agricultural purposes, now sitting in as tidal flats. Okay, so you have high tides coming in and inundating the areas. So it is you in short you lost the land from in that area. So this is the situation. You will come across lot of dead forest because of the inundation and erosion of the tidal waters. These are all examples of the dead forest, and that similar thing we also observed in Andaman after 2004 Sumatra Andaman earthquake. So this is the high ground now. So the people who used to stay here have shifted. Those who survived from this event, they have shifted on the higher grounds here, and some of the remnants of the soil, as I have has been shown here, still exist. Okay, and this is an old soil which was before the 1960 event. So still we have some remnants of old soil there, but now it is subjected to erosion because of the tidal inundation. So what we did was, this is the best way to identify the earlier events, because all such events, either it is earthquake or tsunamis, they will leave some signatures in the sediments. So we looked at the stratigraphy, and this is our team. We both were from India, and the team was been headed by Professor Brian Atwater from USGS, US Geological Survey, and this guy is from Chile, and two guys here, one and here one, another one, they were from Indonesia. So a very small team worked in this area extensively and looked at the signatures of the tsunamis. Now what has been shown here is a very simple process. Okay, so we have like soil before earthquake, and then during earthquake there is the land subsidence is there. So what will happen, and when the tsunami comes, it will deposit the sediments here, and this sediments will get preserved over the time, and we will see the soil is capped the previous tsunami signatures. Okay, and this is what we see exactly in the stratigraphy here. So this is a small trench section which we see is a vertical face of that, where we see the tsunami over here with yellowish reddish yellow color, and below one, the dark one, is your 1960 soil, and then further process goes on and we are having deposition of another soil unit here. So if this process or this phenomena occurred in the past also, we should see similar type of stacking of material. Okay. This is what we got there. Okay. So, we have like in the top, which I was showing in the previous slide, we have this present soil here, and then we are having 1960 sand that is deposited by tsunami, 1960 tsunami. Then we are having another, this is the soil of 1960, which marked the surface during 1960, and then we are having another sand layer which was dated at around 1575. So, what we do is we collect the charcoal samples and then we try to date it, how old the sample is, we know that. Okay. So, we can at least bracket the events during that when exactly it took place. Okay. And then we are having another soil here and another sand layer which is older than this one. So, this is around 1200 to 1300 AD, and then we are having around 1000 AD. Okay. So, we have a series of similar events, and the stratigraphy shows that this area experienced many more similar type of events in the past. Okay. So, if you come to Indian part, the subduction zone part, what we see is that in 2004 a very large area got ruptured. Okay. So, this whole area was fractured or faulted during an earthquake. So, there is a displacement along this area which was almost like 1300 kilometers. So, very large source was available for the tsunami to be triggered, and it resulted into a huge tsunami within very large waves. Okay, which engulfed many locations in the region. So, this has been shown here, the wave heights, and this is the bar which marks the 10-meter height here. Okay. So, it was quite large in some places. Okay. Now, this is just the comparison which has been given between different earthquakes like Sumatra Andaman earthquake, and then we are having the 2011 Tohoku earthquake, and then we are having the 1960 and few more earthquakes from Chile. Okay, which were been identified from the stratigraphic signatures. So, here it has been shown that what is the comparatively rupture areas. Okay, there was around 1000 kilometers. This was very small, almost half of this is 500 kilometers of area ruptured, and here it was around 1300 kilometers. Okay. But what recent findings suggest that, because there was a question that why even a small area of 500 kilometers which was ruptured, but the tsunami heights which was experienced and during that during 2011 earthquake, why it was so high actually. Okay. So, the reason, so what they found was that this earthquake not only ruptured the 500 kilometers area, but also resulted into submarine landslide, which added up the energy to the tsunami. Okay. And that what resulted into the higher waves height. Okay, in this region. So, now with the advancement of science, what we can do is we have the sensors which have been left out in the ocean, okay, which will keep on sending the signals through satellite, and of course, we also have the floating gauges, GPS gauges, which will also talk about that if there is a sudden change in the water level. Okay. So, this will help us in sending the information in terms of the warning, okay, before it reaches the particular location of interest. And apart from this, there are ways to create an awareness amongst the people. Okay. and the ways people are still working on this, that how best we can reach people before time to minimize the hazard and risk. Okay. So, if you understand the from the past experience that how much area got inundated in mega earthquakes or the giant tsunamis, you can come up with hazard maps, and then at the same time you can also identify the areas which we say the high grounds. Okay. So, in US and Japan, what they have done is that they have marked they have put the signboards, okay, which shows that, okay, fine, in which direction you have to move if a warning has been issued. Okay. So, this shows that evacuation way where you have to move. Okay. So, this says evacuation route. Okay. So, which part you have to move, so it will guide you, and then you can reach the closest one as early as possible. Other than that, you have an education and awareness part where you can keep on like what we are doing right now, but what they people have done is that they have created some cartoons, okay, or videos which have been shown, and they have come up with some booklets which are given to the school kids, okay, so that they can understand what best they have to do at the time of tsunami when the warning has been issued. Okay. So, finally, what we see is the tsunami warning has been issued. It will go to the local agencies, and then coastal residents are been informed, and then finally they will go for an evacuation. Okay. This is the picture which we took after the earthquake of 2004, which shows that, so this area is in the northern side of Andaman, northern part of the Andaman, which clearly shows that there was an uplift here. So, this photograph was taken after like almost like in after a month or so, or maybe a week, okay, if I am not wrong, which shows that the water used to come up to this level, and there is a beach here, okay, but later on, because of the uplift, the water is never reached up to this place. It used to restrict the inundation up to this. Okay. So, this area got uplifted or exposed to the surface. So, we had a very good team from here, from IIT Kanpur. We did the survey, and we also involved a couple of army officers who were the students with us at civil engineering department. Okay. So, we conducted a very rigorous reconnaissance survey and looked at the affected area. So, I will just share a couple of slides from there what we did. So, we know that this area, that is the Andaman region, falls under seismic zone 5. So, we had that understanding, but we never had an experience of mega tsunami in recent past. Okay. So, if you look at the tectonic setting of Andaman and the Sumatra areas, and with respect to the Australian plate, or we say the Indian plate. So, what we see is that the Australian Indian plate is subducting, or the Burmese microplate is subducting below the Eurasian plate here, okay, and that is what is been was responsible for the formation of this Andaman or Sumatra Andaman arc here. So, most devastating and second largest earthquake was been triggered with magnitude 9.3. It occurred along the plate boundary marked by subduction zone between Indian plate and Burmese microplate, a part of the Eurasian plate. A recent global tectonic plate reconstruction data suggests that this area or the plate moves in northeast direction with an velocity of 54 millimeter per year. Okay. So, it is quite fast here, okay, in this region. And GPS observations between Bangalore, okay, over here, and the Andaman Islands suggest that the Indian plate is approaching the Burmese plate, at the rate of around 53 millimeter per year. Okay. So, this is a total convergence between the two plates, but if you look at between the two microplates and all that, it is something like 15.3 millimeter. Still it is quite fast. Okay. So, this is the tectonic configuration of the plate margin. We are having the Andaman Trench here, and we have another what we call the Sumatra fault, which is at the back on. This all area is the back arc extension which is going on. And since we had the configuration like one plate is subducting below the another one, okay, we have some volcanic eruptions. So, this is a barren volcano which is the active volcano in the Indian side. So, this whole area which is around 1200 to 1300 kilometers ruptured during 2004 earthquake. Okay. So, what happened was that there was this was 2004 earthquake which triggered on the subducting plate or the overriding plate. The epicenter was just on that, and then it triggered the complete area, and during that period itself, on the same after few seconds or maybe minutes, there was another earthquake of 7.1 magnitude, and then the rupture propagated in this direction and fractured the whole area, okay, covering 1300 kilometers. Now, if you look at this map, it clearly shows that there were a couple of large magnitude earthquakes which occurred in 1941, 1881, 1847 within surface area which has been marked by pink boxes here. Okay. So, this was the only small surface areas or the surface ruptures, okay, which were ruptured by this earthquakes. Okay. But compared to this, they were very small. Okay. But there were signatures of such earthquakes in the past. Okay. Now, what happened in 2004, if you look at the, I'll start presenting some observations which we made from south, and then we will move towards north. Okay. So, dramatic land level change took place, and what we say co-seismic land level changes at the time of seismic event. Okay. So, we say co-seismic land level changes along Andaman and Nicobar Islands. Okay. So, blue ones are shown are here, this numbers are showing the area subsided. Okay. And then this part shows with the shown with the red one, this area uplifted. So, there was a very typical tilt which took place. Okay. So, there was the force was from here. So, this area got tilted. Okay. So, there was a tilt here. So, close to the epicenter, the subsidence was much larger, almost like this is not very close, but almost like 300 to 400 kilometers from the epicentral part, that is in Bandhache. The area was around subsided by 3 meters, and then as we moved further north, the subsidence reduced. Okay. So, we will stop here and we will continue in the next lecture. Thank you so much.